Sometimes you'll be given an equation and it's not in slope-intercept form. You'll need to convert it to slope-intercept form to be able to graph it easily or solve for other variables. So I will show you two examples on how to do that. On the left-hand side, we have 8x plus 2y equals 10. Our goal is to isolate y because slope-intercept form says y equals mx plus b. I'm going to write this at the top to remind us. Our goal is to get y all by itself. So looking at our equation on the left, we can see that we have an 8x being added to our 2y. So we're going to undo that by subtracting 8x from both sides. We're doing the inverse operation. We want to subtract 8x before dividing by 2 because inverse operations say we subtract and add first, then we can divide and multiply. So we subtract 8x. 8x minus 8x is 0, so we're adding 0 to 2y now. That's good. We're closer to isolating y. And then on the right-hand side, we have 10 minus 8x. All right, so now this is saying I've got two groups of y that is equal to all of this on the right-hand side. I want to see what one group of y would be equal to. So I'm going to divide everything by 2. 2 divided by 2 is 1. So we're left with 1y on the left-hand side. 10 divided by 2 is 5. 8 divided by 2 is 4, and we'll keep that subtraction sign. And of course, our x. So we're almost there. In fact, we could use this equation. The problem is that we don't have x listed first. So we can flip-flop these two terms. We know from the commutative property of addition that it doesn't matter which order we add things in. For example, 2 plus 10 is the same as 10 plus 2. We're going to get the same amount no matter what. A key thing to remember, though, is that we've got a subtraction symbol on 4x, and that subtraction symbol has to stay with it. That's our slope. We don't want to change it. So we get y equals negative 4x plus 5. The 5 doesn't have a sign in front of it, which automatically defaults it to positive. Now we know our slope is negative 4 and our y-intercept is 5. So our line will cross the y-axis at 5 and have a rise of negative 4 and a run of 1. All right, let's look at our next example. We're going to follow the same process. We want to get y by itself. So first we add or subtract any terms that are happening here. So we've got a 5x. We subtract 5x from both sides. Notice how I'm just making sure they've got opposite signs, but the same distance from 0. Subtract 5x from this side. 5x minus 5x is 0, so now we're adding 0 to our 1/2 x. To our 1/2 y. I'm tired, can you tell? And that is equal to 6. And then we subtract 5x. All right, almost there. This is saying that half of y is equal to 6 minus 5x. We want to know what 1y would be equal to. So we would divide this side by 1/2, divide this side by 1/2, or since we'd be dividing by a fraction, we can multiply by its reciprocal. 1/2 times 2 becomes 1, yay. So then we multiply all of this by 2. Distributive property coming in clutch here. So we get y is equal to 12 minus 10x. And you can see again, we've got x on the right side of this expression when we'd really like it over here. So we can just flip-flop them. Just make sure that since this is negative, it stays negative. So we get y equals negative 10x. There's our slope, negative 10. Plus 12. Now I do want to quickly add in something I hadn't covered before. What if I had negative 6x plus whatever y, we can just say y, equals 10? Well, we want to have opposite sign, same distance from 0. So we would just add 6x to both sides. The goal is to make sure that whatever we add to y is 0. So plus 6x, y is equal to 10 plus 6x, or y equals 6x plus 10.